All right. We are going to work on subtraction. And I know everybody thinks, oh, subtracting, that's so easy. We've been doing that since kindergarten. Or we've been doing that since first grade. But guess what? This is one of the things that a lot of people mess up on. And it is very important that you subtract correctly. So we're going to take some time and we're going to really think about what happens when we subtract. And then we're going to relate it back to the standard algorithm where we stack the numbers up and we cross them out and borrow. Okay? So you should have that new template in your work map. Okay? I'm going to write a number or a problem. 4,259 minus 2,171. And I want us to think about this. Last week we worked on using tape diagrams to model or represent addition problems. How could I use a tape diagram to represent a subtraction problem? What are you thinking, Christopher?
You can put a tape diagram down.
Okay. All right, here's the tape diagram.
And then you can do see that stuff. You can put a line through the middle, but instead of adding, you have to subtract to get your answer.
Okay. So, what does this 4,259 represent in our problem?
Biggest number. Yeah. A part.
Is it a part?
A part of the problem.
It is a part of the problem, but does it represent a part or does it represent a whole?
Oh.
That's the whole. Yeah, that's the whole amount that I have. That's the total amount that there is. Please do not draw on your place value charts, on your work mats. That's not what we're doing. We're having a math lesson.
We're not supposed to be doing anything.
You're not supposed to be doing anything right now. So I'm going to show that this is the total by making one of those little fancy brackets and putting 4,259 up here. I know that's the whole amount that I have. So how would I put 2,171? Where would that go on our place value chart? Or I'm sorry, not our place value chart, on our tape diagram. Where would 2,171 go? What does it represent, Christopher?
It represents the part that you're taking.
Yeah, it's one of the parts of the problem. It's what part I'm taking away from the whole. So 2,171 I'm going to put as a part.
And then we have to figure out what the other number is.
We do have to figure out what the other number is. You're exactly right. We're going to figure out what this missing piece is, or the missing part. What do I represent that with?
Subtracting.
A variable. Does it matter what letter I use?
No.
No, I can use any one I want. We'll use an H today for this problem since Harper remembered that word variable. So I could represent my problem as 4,259 minus 2,171 equals H. I know I'm solving for the missing part. I know the total. I know one of the parts, and I need to find out what the other part is. All right, so now let's think about how we would represent subtraction on our place value chart. So this number, this problem, has ones. It has tens. It has hundreds. And it has thousands. Okay. What number would I represent on my chart?
You represent 4,259.
I'm going to represent 4,259. So right now, on your place value chart, I want you to put 4,259 on your place value chart using place value discs.
Do you want us to start writing it now?
I want you to put the number 4,259 on your place value chart using place value discs.
What are we doing?
You are putting 4,259 on your place value chart using place value discs.
And then, wouldn't you put under it the number that you said?
That's all you're doing right now. Alright, so let's check and make sure you have the correct amount represented. So we're going to look at our thousands place. How many place value discs should I have in the thousands place value? 4. Let's count them. 1,000, 2,000, 3,000, 4,000. How many place value discs should I have in my hundreds? 2. 100, 200. Okay, let's check the tens. How many should we have?
5.
Count them. 1, 2, 3, 4, 5. 5 tens. And how many ones? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Do I need to draw 2,171 on my place value chart now?
What? No.
Why not? I agree with you. Why not?
Because you already drew it right here.
What am I doing in this problem?
Subtracting.
I'm taking them away. I'm not adding more.
So
I'm taking away. So I'm going to just write this same problem down. 4,259, 2,171. I'm subtracting, so I've just written it vertically. And you can go ahead and do this at the bottom space on your work map.
So you want us to put the problem at the bottom?
Alright, so if I were just going to look at my problem that I wrote down vertically, where do I start? Which place value do I start in, Ansley?
Well, I know how to solve it on the place value chart.
Okay, the only question I'm asking right now is what place value we start when we're subtracting. The ones. So I'm going to look at my ones, and I'm going to see if I have 9 ones, can I take 1 away? Yeah, so I can go ahead and do that. I'm going to switch colors just to make it easier to see up here. So if I go up here to my place value chart, to my ones place, I have 9, and I need to take 1 away. How can I show that I'm going to take 1 away, Jacob?
1 away.
How could I show that on my place value chart?
You could circle 1 and take it.
Okay, what's another idea?
You could X out.
I could just X it out, whichever you choose to do. I'm just going to put an X on one of them. Does it matter which one I take from? No. I'm just going to X one of those out to show that I'm taking it away. And that leaves me with how many?
8.
8. I have 8 ones. 9. If I come to my ones place value, 9 minus 1 equals 8. Did I show that on my place value chart? I did. All right. So now we're going to move to what? To the tens. So I have 5 tens, and I need to take 7 tens away. Can I do that, Ansley? No, I cannot. Why not?
Because 5 is not bigger than 7. So
Yeah. Yeah, if I start looking at my tens, I can cross out 1, 2, 3, 4, 5. But I still have 2 more I need to cross out.
You would take
Okay, so what do I need to do, Ansley?
you need to cross out the 1 and borrow 100 from it.
Okay. So I need to take one of these hundreds, and you said borrow. So when I borrow, what am I really doing?
You're taking 1 from that number.
Yeah, I'm going to take one of my hundreds, and I'm going to make it into tens.
And it'll 5 into 15, which then you can.
So if I take this 100 and I make it into tens, how many tens do I put in my tens column to equal the same amount?
15? No, not 15.
100 is equal to how many tens?
10.
10. So I'm going to put 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's look at how we would represent that on the place value. On our problem. We've represented it on our place value chart. How would we represent it in our problem? How many tens do we have now, Cash?
10.
How many tens do we have?
15.
I had 5, and I added 10 more. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How am I going to show that this is not a 5 anymore, that it's 15? Yeah, I'm going to cross it out, and I can either write 15 up top, or if you have some other method that works for you, I like just putting a little 1 in front. That's okay, but it's usually easier to see if you just go ahead and write the number up above. Is that all I need to do to my problem?
No.
What else do I need to do, Ansley?
You have to subtract 7 from 15.
Oh, am I finished with... Am I finished here?
No, you have to cross out the 2 and put 1 on top of it.
Why am I crossing out the 2 and making it into a 1? Because why, Ansley?
Because you took away 1 from it, so now it's 1.
Huh. I took this 100 and I made it into tens. So now I only have 100 left. But I have 15 tens now. So we've already represented the 15 tens. And we've shown that we only have one group of 100 left. Now can I subtract 15 minus 7? Can I do that now?
Yes.
I have 15 tens and I need to take 7 of them away. So I'm going to cross out how many?
7.
7. Does it matter which 7?
No.
Nope. 1, 2, 3, 4, 5, 6, 7. How many tens do I have left?
8.
8. 15 minus 7 equals 8. I can count and see that I have 1, 2, 3, 4, 5, 6, 7, 8 left. Now what place value do I go to? What do I do next?
You go to the 100.
Okay. So how many hundreds do I have?
1.
1. How many am I taking away?
1.
1. So
0.
I can do that. I could just cross out the 1 that I have left, and that leaves me with how many?
0.
0. Okay. So I have no hundreds left. Now what do I do? Last place value we have in this problem.
Take 2 away.
Oh, hang on, Jacob.
4,000. What Jacob said, 2 away from.
Yeah, I have 4,000s, and I'm going to take 2 of them away. And that leaves me with how many?
2.
2. So, what does H equal?
2,088.
2,088. Our other part is 2,088. H is equal to 2,088. What could I use to check my answer to see if it's correct? What could I do to check my answer to see if it's correct? Do I know my parts now? Can I put those two parts together to see if it equals the total? Yes, because addition and subtraction are inverse properties. That means they're opposite each other. So we've proved on our tape diagram that we can use addition to check. Let's do that real quick. So I'm going to add 2,171 plus 2,088. If I add those together, 1 plus 8 is 9. 7 plus 8 is 15. I'm going to write down the 5. Carry the 1 over. 1 plus 1 is 2. And 2 plus 2 is 4. 4,259. Is that the total that we have? 4,259 was our total. So I know that my two parts are correct. All right, very good. You may erase.
Erase.
So those tape diagrams will help you when you're solving word problems. If you think about, in your word problem, if you think about what's the total and what the parts are, that can help you decide what you need to use to solve. All right, let's try another one. This time we're going to do 23,422 minus 11,510. 23,422 minus 11,510. I want you to take just a minute to draw a tape diagram. We're not going to use our place value chart this time. I want you to draw a tape diagram to represent this number or this problem.
I still don't get how to use tape diagrams completely. I'll try. I forgot what a tape diagram was. Them straight lines.
Alright, I know a few of you aren't finished. That's okay. Let's check our tape diagram. I've got my rectangle, and that represents the whole amount or the total that we have. Do we know the total amount that we have in this problem?
Yes.
What's the total amount, Owen? 23,422 is the total. Do I know a part? Harper, what's a part that I know?
11,510.
I know that I have 11,510 as a part. Do I know the other part?
No.
Okay, this time I'm just going to use a B. I'm going to use a capital B because if I use a lowercase b, it kind of sometimes will look like a 6. So just to keep it from looking like a number, I'm just going to use a capital B. Is that okay if I use the capital?
Yeah.
Yeah, it doesn't matter if I use an uppercase or lowercase number. So how did I know to put 23,422 at the top of my tape diagram? Why did we put 23,422 up here? Why, Christopher?
Because it's the whole.
It's the whole amount that I have. It's my total. And then I put 11,510 inside of the tape diagram because it represents a part.
Yep.
All right. So we're going to see if we're ready to subtract. We're going to look across the digits and we're going to see if we are ready. Can I do 2 minus 0?
No. Yeah.
Yeah, I could take 2. Okay. Can I do 2 minus 1?
Yeah.
Can I do 4 minus 5?
No. Yes.
I hear a no and I hear a yes.
No. No.
Prove to me why you can't do 4 minus 5, Christopher.
Because 4 is below 5.
Yeah, if I have 4, I've got to have something else. I'm going to end up with a negative number if I don't. So, what am I going to do to subtract 4 minus 5?
You can take
You can
one
take
from
some-
5, but
You can take 1,000 over, and then you can add it to 100. You can
Hmm?
take 1,000 minus 5 or 14.
So,
14 minus 5.
so instead of having 3,000, how many thousands will I have?
2.
2. I'm going to take one of my thousands and I'm going to make it into hundreds. How many hundreds does it take to equal 1,000?
10.
10. And I have 4 already, so 10 plus 4 is
1,400.
14. Okay, 1,400, you're right. So I have 14 hundreds.
That minus 5.
Now can I do 14 minus 5?
Yeah.
Yeah, so now my hundreds are ready.
That's
If I move over to the thousands, can I do 2 minus 1?
yeah. Yeah.
Can I do 2 minus 1 in the 10,000s?
Yeah.
Okay, so I'm ready to subtract. Where do I start?
1.
1's place value. 2 minus 0 is 2. 2 minus 1 is 1. 14 minus 5 is 9. 2 minus 1 is 1. And 2 minus 1 again is 1. So what's my missing part?
11,912.
11,912. We could say B is equal to 11,912. So is subtraction hard?
Nope.
No. Is it easy to get in a hurry and mess up?
Yes.
Yeah. So
That's what happened to me.
okay, so take your time when you're subtracting, just like anything else. You're going to take your time and make sure that what you're doing makes sense. All right, we're going to do one more together. So erase your work map.
Erase. Are we using tape diagram or?
We are. We're not going to use our place value charts. We're going to subtract this problem. I'm going to write it down. This time, what variable do you want us to use, Brayley? A variable. Which variable do you want to use? Can be any one, just pick. Doesn't matter. C. All right. We're going to use C, and lowercase or uppercase C don't really look like a number, so we can use either one. 29,014 minus 7,503. So first, if I start with drawing a tape diagram, I see a few of you have already done that. What's my total?
29,014.
29,014 is my total.
And then your fragment or your part is 7,503.
7,503 is my part that I know.
Okay, I get how to use tape diagrams.
And then the unknown number is 2.
And then I'm going to use a C to represent the unknown. I want you to look at something for just a second. Do you notice anything about where I divided my tape diagram?
Yeah, one side's bigger than the other.
Why do you think I might have made one side bigger than the other, Jacob?
The other side might be bigger.
Because the burial might be bigger.
Yeah. Now, I'm not going to count you wrong if you divide it in the middle. But just thinking, if I use a little bit of number sense, I know if I have 29,014 as my total, and I take away 7,503, I know that my other part's going to be a lot bigger, right?
Yeah.
Because I'm going to have more than 10,000.
Yeah.
Work it out.
Because it's lower than it's lower than the 10,000.
Yeah. Yeah, so I just made it bigger. It's okay if you don't, but that is something you can think about using some number sense. I know that my answer is that my missing part is going to be a lot bigger than the part that I already have. All right, so now I want you to write this problem vertically on your work map. Vertically.
Wait,
So that means up and down.
I already did this.
All right, I want you to look at mine. Cash. Cash. We're not drawing on our work mats. We're using them as a tool to solve.
No, I'm making my.
You don't need to do this to make a tape diagram. Okay. Look at how I wrote this problem vertically. Did I write that correctly?
Yeah.
Why not? Why is this not correct?
It's not in the correct place value.
They're not in the correct place values. When I'm writing a problem, and it doesn't matter if I'm adding or subtracting, when I write a problem vertically, I have to make sure that I line up the correct place values. So I have 4 ones, and I'm taking away how many ones?
Take away 3.
I'll take away 3, so that 3 has to be right underneath
So it's 1.
the 4 in the ones place value. I have 1 10, and I'm taking away 0 10s. So I'm going to put the 0 right underneath the 1. Have 0 hundreds, and I'm taking away 5 hundreds. I'm going to put my 5 right under the 0. I have 9 thousands. I'm taking away 7 thousands. So the 7 goes right there underneath the 9 in the thousands place value. I have 2 10,000s, and I'm taking away no 10,000. So do I need anything underneath the 2? No. Because it's at the beginning of the number, so I don't have to represent that. Okay, so let's look and see if we're ready to subtract. If I look at my ones, can I do 4 minus 3?
Yes.
Can I do 1 minus 0?
Yes.
Moving over to my hundreds, can I do 0 minus 5? So what am I going to have to do, Jaden?
So you're going to have to get your 9 and turn that into an 8 and turn it into your 0 into a 10.
Very good. I'm going to take one of my thousands, and I'm going to make it into hundreds. Why did you say I needed to make it into a 10, Jaden?
Well, because it's easier for me to do 10s other than 100s.
Okay. So if I have 1,000, I took one of my thousands away, and I'm going to make it into hundreds. How many hundreds does it take to equal the same amount as 1,000?
10.
10, yeah. And I didn't start with any, so I don't have any to add to it. So that's just going to be a 10. Okay, looking at my thousands, can I do 8 minus 7?
Yes.
Yes. Can I do 2 minus nothing?
Yes.
Okay, so we're ready to subtract. 4 minus 3 is 1. 1 minus 0 is 1. 10 minus 5 is
5.
8 minus 7, 1. And 2 minus nothing is 2. So what does C equal? 21,511.
I just estimated.
Okay. All right. I want you to do some practice on your own. Open up your Learn book.
Okay. This is gonna be fun. What page?
You need to get out page 87 and 89. No, wait, hang on. Sorry, that was the wrong pages. Page 95. Yes, you may go get all of your things. Learn book, page 95 and page 97. Page 95 and page 97. Okay. We're going to start with our application problem, but I'm going to go ahead and have you circle the problems that I want you to do first on page 97. So I need you to get your pencil on page 97. I want you to circle on page 97 on number 1, which is the ones that the problems are stacked vertically.
Yep.
Okay? I want you to circle A.
Wait, on what page?
I want you to circle E.
1 second. Can't find the pencil. Find pencil now. Can't. Wait a second. I don't know what page to be on.
I want you to circle G.
What? What's that?
I'm writing them on the board, so if you miss something, you can go back and look. H and I. So on number 1, you're circling A, E, G, H, and I. Then you're circling number 2. On the back, you're circling 3, 4, and 5.
So you only have to circle. Tear out 95, not 90.
Then I want you to go back, flip back over to the side, to the front side, and let's look at the directions.
I don't have a pencil on a pen.
The directions say draw a tape diagram to represent each problem. So do I want you to draw a tape diagram?
Yes.
Yes. Use numbers to solve. So you're going to draw your tape diagram. Then you're going to solve by stacking those together and using them vertically. And then it says, and write your answer as a statement. Hey, Cash, hang on just a second, okay? What does it mean to write your answer as a statement?
By using some of the answers.
Yes.
Statement.
That's right. You're going to use that question and make it into a sentence that tells you what the answer is and what it means. Then it says to check your answers. You may go ahead and get started.